All right, guys. So on this coloring activity, you have some more examples. These have a little bit more challenging problems on them, so I recommend trying these out if you find the other one a little too easy. So you can kind of read the directions yourself here if you want to do the coloring part of it. I'm going to show you just a few examples off of these. I'm going to start with this blue one here on the right-hand side. All right, so keep in mind, whenever you have multiple fractions within your equation, your goal is to eliminate them, okay? So I want to do that after any distributive property that I have. So in this blue one here, I don't have any distributive property, so I'm going to go ahead and eliminate those fractions now. So again, I look at the denominators. I have a denominator of 3, 5, and 5. So really just 3 and 5. I don't have to count the 5s twice. So again, I'm looking for common denominators. So if I were to list the multiples of 3, I would say, okay, 3, 6, 9, 12, 15, 18, and so forth, right? Now, if I did that with 5, so 5, 10, 15, oh, okay, I found one in common. And that's the lowest one in common, okay? So 15 is going to be my least common denominator. So that's what I multiply my entire equation by, is 15. Okay, not a negative 15. So since I'm dealing with fractions, I'm going to go ahead and put that 15 over 1 just right away. So when I go to multiply, 15 times x is just 15x. Okay, next I have 15 times a positive 1/3. Remember that plus sign goes with it. So I'm going to go off to the side. So 15 over 1 times 1/3. Okay, multiply straight across. So that gives me 15 over 3, which just gives me 5. So that's a plus 5 here. Next, I go to 15 times a negative x over 5. Okay, so I have 15 over 1. Again, you're going off to the side. Times a negative. So remember that negative I either want to put on the numerator or denominator, but not both because I want to keep it negative. So I'm going to put it on the numerator. And that says x. But remember, I can put a 1 here. And anytime there's x by itself or a variable by itself, put that 1 in front of it. And then that was over 5. So now I can multiply across. And that's going to give me negative 15x over 5. Well, I know it's going to have an x with it, but negative 15 divided by 5 here is going to be negative 3. So this is going to be equivalent to negative 3x. So that's a minus 3x here. Bring down my equal sign, and now I'm multiplying that last side. So remember, when you're multiplying by the least common denominator, you want to multiply it by both the left-hand side, whatever's on the left-hand side, and whatever's on the right-hand side. So again, I'm going to erase some of this so I have more room to work. Okay, so I have 15 over 1 times a negative, again, I'm putting in the numerator, 3/5. When I multiply that across, I know that's negative 45 over 5, which ends up just giving me a negative 45 divided by 5 is just negative 9. So equals negative 9. So now at this point, I just have whole numbers to work with, okay? Or integers, whatever. So I'm going to, okay, still no distributive property to deal with. Next is combining like terms. Well, I have two like terms right here. So 15x minus 3x is going to give me 12x. Bring down that plus 5. Bring down the equals negative 9. Next step, no more combining like terms. So now I can go in the inverse order of PEMDAS. So adding and subtracting comes first. Subtract that 5. So I have 12x equals, well, think about dojo. If I'm at negative 9 and I get a minus 5, I'm going to be at negative 14. Divide by 12. That is my last step using that inverse operations. So now I'm left with x equals, okay, well, I could actually divide this out, and I'm going to go ahead and do that. Well, I have a negative divided by a positive, so I know automatically it's going to be a negative number. So if I go off to the side and say 14 divided by 12, And keep in mind, since there is already fractions within my equation, I want to make sure that my solution has a fraction as well. Okay, so 12 will go into 14 one time with 2 left over. So whenever you have a remainder, we're not going to go into a decimal. We're going to put that remainder over the divisor, and 12 is our divisor. And then simplify. So I can simplify that to, that's 1 whole, and then 2 twelfths can simplify to 1/6 if I divide both of them by 2 over 2. So my solution here should be -1 and 1/6. You may see on the answer key the negative, oh, I erased some of it, negative 1 and 1/6 being the same as -7/6, which is the exact same thing. Okay, moving on. I'm going to pick a different one. Okay, I'm going to choose this blue one here now. So again, I want to get rid of my fraction, but I need to take care of the distributed property first. So in this case, I actually have the distributed property. So I'm going to go ahead and do that multiplication first. So I have 3 halves times 3x. Remember, I can put that over 1. So when I multiply across, that's going to give me 9x over 2. Okay, so I have 9x over 2 as my first term. Then I'm going to be multiplying that positive 5. So again, coming off to the side, so that's 3 halves times 5 over 1. And that gives me 15 halves. So that's plus a 15 halves. Okay, and I still have that equals -24. All I did was take care of that distributed property. Now, when I look at this, I'm looking at my fraction to get rid of that fraction next. Okay, so I have just a denominator of 2. So I don't need to find that common denominator like I did the last problem. It's already 2. There's no other ones besides 1, technically. So I'm going to multiply this entire thing by 2. And I'm going to put that over 1 since I'm dealing with a fraction. Okay, so when I multiply 2 times 9x, well, 2 over 2 gives me 1 whole. And that's just saying 1 times 9x. Okay, well, that just leaves me with 9x. And the same thing with this one. So when I say 2 in the numerator and I have a 2 in the denominator, well, that just gives me 1 whole times 15. Well, that's just going to be 15. And then, since I'm getting rid of the fraction, I have to do it to all of the terms inside my equation, okay? It's not quite like the distributive property because I'm doing both the left-hand side of the equal sign and the right-hand side. So now I actually have to do 2 times -24, and I can't just cancel things because nothing's going to make a whole here. So that's going to be -48. Well, now I have all integers, and I can go ahead and solve. So don't have to combine like terms, don't have distributive property. So I can go in the inverse order of PEMDAS. So subtract 15, subtract 15. That's going to give me what? -63 equals 9x. Last step, I'm going to divide by 9 to get x by itself. So x is going to be equal to, well, -63 divided by 9 gives me a -7. So my solution here should be -7. Remember, if I want to go check that, I'm going to substitute that into my original and see if it actually works out and gives me a true statement. Okay. We'll do one more. Which one was it? Okay. I am going to do the one that says black here on this screen. And it has a lot of fractions going on. But no big deal. We can take care of that. So, again, in order to take care of the fraction, I want to make sure that I've done every distributive property first. So, looking at this problem here, well, I don't have any distributive property, so I don't really have to worry about that. So now I can just look at my denominators. So I have a 9, and then a 2, and a 3. Okay, so I have 3 different denominators this time, not just 2. So, again, eventually, if you don't have to write this part out, that's okay. Remember, we're going to find the least common denominator. So I can kind of write my multiples. So 2, 4, 6, 8, 10, 12, I'll keep going if I need to. 3, 6, 9, 12, 15, 18, okay, 9, 18, okay, I'm seeing two 18s so far. Let's see if 2 can get up to 18 and see if that's our lowest one. So 12, going up by 2s, 14, 16, and 18. So it looks like 18 is my least common denominator. So that's what I'm going to be multiplying this entire equation by to get rid of all the fractions. So again, I'm going to put 18 over 1. All right, so when I start multiplying, I can go off to the side again and say, okay, 18 over 1 times 7x over 9. Okay, so if you don't remember this, I'm going to kind of reiterate this. So if I'm looking at my cross products, so 18 and 9, I can simplify before I actually multiply straight across, okay? So I know that 9 will go into both 18 and this 9 down here. So I can divide 18 by 9 and get 2, and do the same thing here and divide by 9 and get 1. Now I've simplified and I can multiply straight across. So I can say 14x over 1, or just 14x. Okay, so I'm going to list that as my first term. If you're not comfortable with what I just did, you can go ahead and multiply 18 times 7x and 1 times 9, and then just simplify. You should still get 14x whenever you divide at the end. All right, next one. I have 18 over 1 times a positive x over 2. Remember, when there's an x by itself, just put that 1 in front of it. So I have 18x. So again, I'm not going to do what I just did to simplify. I'm just going to multiply straight across to show you. So 18x divided by 2. When I divide that out, that gives me 9x. So I have plus 9x. And next, I have 18 times, that's a negative, okay, so that negative goes with it. So negative 17 ninths. Okay, so I have, where am I going? So I have 18 over 1 times a negative 17 ninths. So in this case, since I'm going to have to multiply 18 times 17, yeah, I can use a calculator and just simplify at the end, but I'm going to try that first strategy that I showed you. So 18 and 9 can both be divided by 9. So divided by 9, that gives me 2. That's a 2. Divided by 9, that gives me 1. Leaving me with negative 17. Oh, sorry, not negative 17. Whoops. Try that again. So 2 times negative 17 gives me negative 34 over 1, or just a minus 34. And then I have the equals, and now I have to go to my last step here. And we're going to go 18 over 1 times that 2/3. So I'm going to come up here. So 18 over 1 times 2/3. So I can multiply across. I'm going to do some of that cross canceling. I'm going to pick a different color. It's hard to see. So 18 and 3, when I'm looking at these two here, well, they can both be divided by 3. So I'm going to divide each of them by 3. So that gives me 6 when I divide by 3. And 3 divided by 3 just gives me 1. So now 6 times 2, I can multiply straight across and say that's 12. And then 1 times 1, well, that's going to give me 1. So I have 12 over 1, or just 12. All right, now I don't have any fractions. I can go ahead and do whatever distributive property is left, which there isn't. Second, combine like terms. All right, I do have some like terms here, so I'm going to do that next. So 14x plus 9x should give me, what, 23x? Bring down that minus 34, and that equals 12. And next, I need to go in reverse order of PEMDAS, so adding and subtracting comes next. So I'm going to use the inverse and add 34 to each side of my equal sign, balancing it out. So I have 23x equals, that gives me, what, 46? And last step, I only have division left because it's the inverse of multiplying, leaving me with x equals 2. So If I were to substitute that back into my equation, I should get a true statement. Okay? So, if you need any help, we can also set up a Google Meet. There will be one today. Keep a lookout for the time, all right? Good luck, guys.